Hey guys, we're back. In this video, we're going to be looking at how we solve logarithmic equations. Let's say I gave you, I don't know, the square root of x equals 9. Okay? Solving it, I believe you would tell me to raise both sides to the power of 2, and that would yield x equals 81, right? I mean, that's what you would tell me. So looking at this, remember, if you're wondering, why isn't it positive negative 81? Well, no, because square roots have a restricted domain. So here, our domain for our square roots, our x value is greater than or equal to 0. So therefore, that's why we don't have a negative 81 when we square both sides. So just using inverse operations still, talking about restricted domain and how that affects our answer. Let's see how that applies to logarithmic equations. So jumping right in. So starting with our basic example. Say we have the natural log of x equals 2. Okay? Before, we wanted to isolate the exponential term, and that's still true here. We want to isolate our logarithmic term. Well, it's already done for us. And then after we isolated the exponential term, then we took the log of each side. Here, we're going to exponentiate each side. So we're going to exponentiate each side, and in doing so, we have to use the base of our logarithm. So I can't use any number. I'm going to have to use the base that's here. So when we raise each side, it's going to look like this. So that's what it looks like when I say exponentiate each side. So the reason we do this is e to the natural log of x, one of its properties is that it just condenses down to just x, and then we get e to the power of 2. And when we evaluate this, it is approximately, if you did not know this, on our graphing calculator. By the way, that's not an error. I am the best. Apparently this doesn't know who I am. Yeah. Anyways, e to the power of x is right with natural log. So I'm going to hit second natural log. There's e to the power of 2. And it's approximately 7.3890. Now, I want to mention this. We don't actually have to deal with it here, but natural log, any logarithmic function, its domain are values greater than 0, x values greater than 0. So we have to pay attention to that. So if I would have gotten a negative value, it would have been an extraneous solution, okay? So we have to pay attention to the domain with the logarithmic functions. So let's try another. So let's say we have 5 plus 2 log base 4 of x equals 4. Well, here we have to isolate the logarithmic term by subtracting 5, leaving us with 2 multiplied by log base 4 of x equals negative 1. We divide by 2, giving us log base 4 of x equals negative 1/2. And we exponentiate each side. Recalling that our domain, our x values have to be greater than 0. It can't equal 0 either. It has to be just greater than 0. Just pay attention to that. So we're going to raise both sides, looking at the base, we're going to raise both sides using log base 4. Okay, so these two cancel, leaving us just x. And we have 4 to the power of negative 1/2, which is showing each individual step. The negative 1/2 is actually 1 over 4 to the 1/2, which is 1 over the square root of 4, which equals 1 over 2. Why can't it be positive negative 2? Well, because our x values have to be greater than 0. And we get a solution of x equals 1/2. Okay, so let's try another. So let's go for something a little more complex. So let's say we have log base 3 of x plus log base 3 of x squared minus 8 and equals to log base 3 of 8x. So we're going to pay attention to the domain at the very beginning. So here, the x values have to be greater than 0. On the right side, the x values have to be greater than 0. But when we look at this term, it's not the case. So I could have, let's say, if x is 1, I would get a negative number in here, and that's not good. So I need to say that x squared minus 8 has to be greater than 0. So in solving that, I find that x has to be greater than the square root of 8, or x has to be less than negative square root of 8. Okay? So we've talked about how to solve that, but even here, something interesting. If x has to be greater than 0 for these two, again, x has to be greater than 0, what can we say about this domain? What we can say is this second result is actually excluded because x still has to be greater than 0 for these two. So finally, what we're going to say is whatever solutions we get, our domain has to be this. Okay? So we'll come back to this. By the way, the square root of 8, for those who don't know this, is roughly 2.82. Just so we have something to refer to. Okay, so solving this. I'm going to use the product rule. See, in the addition, and the bases are the same. I'm going to use the product rule, which says that I can combine addition with a product. Okay. Simplified this in here. X cubed minus 8x, okay, equals log base 3 still of 8x. Now I'm going to exponentiate both sides using 3. Logs will cancel, leaving us with x cubed minus 8x equals 8x. And we're back to an algebraic equation, believe it or not. Subtract 8x, which results in x cubed minus 16x, which equals 0, and I see an x term I can pull out, factor out, using correct terminology. So when I factor an x out, we get x squared minus 16. Factoring x squared minus 16, we get x plus 4 and x minus 4. So we would say that our possible solutions are x of 0, x equals negative 4, and x equals positive 4. Well, we know x has to be greater than 0. And we're checking, is this x value greater than the square root of 8? Well, yes it is. So both of these will be considered extraneous, the x of 0 and x of negative 4. And our actual solution to this whole entire logarithmic equation is x equals 4. So to close on this video, I just want to write down is that we will need to recognize the domain and watch for extraneous solutions. Okay? So this is only for logarithmic equations that we're going to need to pay attention to this because logarithmic functions have a restricted domain, so we have to note what it is before solving. Okay? So we're going to discuss more of this process along with exponential equations and that solving process when we return to class. But until then, post any questions or comments, ask any questions that you can, and I can do my best to answer those questions. But until later, I'll see you then.